Okay, so what we're looking at today is the Christmas exam question on U values. Alright, so part A, calculate the U value of the external wall of a house built over 30 years ago given the following data. So there's a few things to note. Again, the first column here, highlighted in the purple box, that gives you all the layers that have a thickness. Okay, so it gives you all the different layers inside the building, and it also gives you the thickness of each layer. Now with all those thicknesses, you have to divide each one by 1,000. Okay, so for example, the external render is 19 divided by 1,000 equals 0.019. Okay, and that's the figure that you put into the table. Okay, so the next box then, green, that's the thermal data of the external wall. Okay, so here you're going to be given the figures for the resistance of each surface. You could be given the resistivity, you could be given the conductivity. Okay, so the next thing then is to draw a sketch of the detail that you're actually dealing with. So again, the green layer here on the outside is number 1, and that's our external surface. Number 2 is our external render or plaster. 3 is the concrete block. 4 is the uninsulated cavity. 5 is our inner concrete block. 6 is the internal plaster, and 7 is our internal surface. Okay, now it's very important to number them like that because it just makes your table a lot clearer in the next step. Okay, so we start part A of the question. So the key to these questions is, first of all, you have to find the resistance of each layer. Okay, now if you look at the column here, we're actually given some of the resistances. So we're given the resistance of the external surface, the resistance of the cavity, and we're also given the resistance of the internal surface. Okay, so what we have to do again is we have to write down the formulas. Okay, so the formulas to find the resistance, first of all, are these ones highlighted here in the purple box. Okay, so it's resistance equals thickness over conductivity, and resistance equals resistivity multiplied by thickness. Now if you look at the thermal data of the wall, the part there that's circled in orange, you can see that there's actually no small r value. Okay, it's because there's no small r value, we actually don't have to use this formula. So if we're looking for, we'll say, the resistance of the concrete blocks, we know we have to use the formula thickness divided by conductivity. Alright, so the next thing then is to draw the table. So that's the table drawn for us with all the different layers included. Now because we don't need a resistivity, we can actually blank off this column here. So we won't need to fill in any data in here. So either don't draw it or just blank it off so that you don't put in the figures into the wrong tables. Okay, so we'll start layer by layer. So the external surface first of all. So we check the first column, this column here, to see if there's any thickness. So we know now that the external surface doesn't have a thickness. Check the next column. So we say the thermal data of the external wall. You can see there the very first line says resistance of the external surface, the big R, is 0.55. So we're going to put that straight into the column here. So the big R column, so it's 0.55. Okay, so again, next column after that, so conductivity is blank, thickness is blank. So the external render next. So the external render again, thickness is 19. So remember we had to divide them by 1,000. So the thickness was 0.019. We look into the thermal data of the external one, and we can see the conductivity of the external rendering is 0.460. So 0.460. Okay, so we can see there we have the thickness and we have the conductivity. So if we use that formula then, so it's R equals T over K, we should get a U value of 0.0413. Okay, same thing for the concrete block. So again, check the top layer there, or the top block first of all in green. So we have concrete block at the outer leaf, perfect, it was 100. We need to divide that by 1,000, which would give us 0.1. Then we have to check our second block here in blue. So we have the conductivity of the concrete block, the K value of it again is 1.440. So we put 1.440 in the conductivity column. So we had the thickness, we had the conductivity, so we have to use the formula R equals T over K, and that will give us a resistance of 0.0694. Now be careful to make sure that you have the decimal point in the right place, and that you copy the figures down from the calculator correctly, because that's where a lot of people go wrong. Okay, so the next thing then is our cavity. So number 4 is the cavity. We have the thickness here of an uninsulated cavity, so we might as well put that in, 0.1. Okay, in the thermal data we're actually given the resistance of the cavity then, so all we have to do is go to the resistance column, and it's 0.18. We don't have the conductivity, so we can leave that blank, but we have the resistance, so it doesn't matter. Okay, concrete block is going to be the same as the last one, so it's 1.440, it's 0.1 in thickness, and that's 0.0694. Okay, internal plaster then again, so the internal plaster thickness is 16 divided by 1000 is 0.016. We also have the conductivity of the internal plaster, so the K value is 0.460. Again, so we have the conductivity, we have the thickness, we use the formula T over K, and that will give us 0.0347. Okay, when you put into your calculators. Okay, so the last layer there is our internal surface. So the internal surface, if we look at the thickness, we don't have any thickness for it, but we have the resistance here, the very last line. So the resistance of the internal surface, the R value, is 0.123. So that's 0.123. That's blank, and that's blank. Okay, so be very, very careful now adding up the resistance total. So that's the next step now. So everything in this column here, in the resistance column, needs to be added up together. Okay, now be very, very careful doing this, because this is where a lot of people go wrong. Okay, so if we added all them up together, we will get a total resistance of 1.0678. okay, so with that then we have the total resistance. So what we have to do now is we have to find the actual U value. So we have the U value formula over here. So it's U value equals 1 over RT. So that means U equals 1 over RT. That equals 1 over the resistance total, which is here. So that's 1.0678. And when we put that into the calculator, you should get 0.936. And that's watts per meter squared Kelvin. Okay, so part B of the question is: the owner wishes to upgrade the thermal properties of the wall and has chosen to use the external insulation method of fixing expanded polystyrene to the external surface. So basically what he's doing is he's adding external insulation to the outside of his house. Okay, so given the thermal conductivity K of the expanded polystyrene is 0.037, calculate the thickness of insulation required to achieve a U value of 0.27. So our target here, our target U value is 0.27. We're also given the conductivity of the expanded polystyrene, so that's our insulation, as 0.037, and we'll be dealing with that later in the question. So first off, our target U value is 0.27. We already have a U value of 0.936 from part A of the question. Okay, so what we need to do now is we need to convert the two of these into resistance. So to do that, we're going to use the formula R equals 1 over U. So the target U value equals 1 divided by 0.27, and that'll give us a resistance of 3.7037. Our current U value is 1 divided by 0.936, and that equals 1.0678. Okay, so now that we have the resistance of each layer, we don't need to include the current resistance. So we already have a certain amount of resistance. Our target is 3.7037, so we need to take our current away from the target. Okay, so when we do that then, so our target resistance again is 3.7037. We're going to take away our current resistance, which is 1.0678, and that'll give us a U value of 2.6359. Okay, so next thing then is we want to calculate the thickness of insulation required. So we need to use the formula T equals K multiplied by R multiplied by 1000. So that's thickness equals conductivity multiplied by the resistance multiplied by 1000. Okay, so that 1000 there, just so you know where it's coming from, is at the very start of these u-value questions we divided everything by 1000 to convert millimeters into meters. Now we're going to change it back into millimeters. So by multiplying by 1000 now, we're changing from meters back into millimeters. Alright, so we just fill in the blanks then again. So T is what we're looking for, the thickness. So we have K multiplied by R multiplied by 1000. Our K value was given to us in the question, so that's here. So the conductivity of the expanded polystyrene is 0.037. Our resistance is given here, so that's 2.6359, and then it's multiplied by 1000. So when you multiply that out together, you get 97.5 millimeters, and you can round it up or down to 97 millimeters and 98 millimeters.